Let's see. It doesn't appear to be showing up. Oh, no, we're definitely live. Okay, welcome to Algorithms Live. This week is an episode on AtCoder, and we have a special guest joining us this week. So many of you may know him. It's Makoto Soejima. He's the admin at AtCoder. You may know him by his handle RNG58. So Makoto was the SRM coordinator for 2011 to 2015, and he's currently the admin at AtCoder. He's been the TCO champion 3 times at TopCoder Open 2010, 2011, and 2016, and also won Google Code Jam in 2011. And then he's a 2-time gold medalist in ICPC World Finals in 2015, 2013, placing 3rd place each time. And if you haven't started following his new blog on competitive programming, it's definitely something to check out. It's really cool. So Makoto, thanks for coming on the show.
So should I say something?
Yes. Just say hello.
Hello.
Okay, so I guess we'll get right into questions. So the first question I have is, what is the story behind the creation of AtCoder, and how did you become admin?
Yes. Actually, it is not me who studied AtCoder. Do you know Chokudai?
What's the handle or name?
CHOKUDAI.
KUDAI. No.
Maybe no C, not G. Maybe you can
like this?
D.
Is this correct?
No, G should be C, and T should be D.
Like this?
T should be D. Maybe I can type it in the comment.
Or you could type it in GChat for me.
Yeah, it is.
Because I have that open.
And he studied AtCoder, and I joined them.
Ah, cool.
Yes. And I wanted to start an international contest with good programs, and he agreed to start such a contest, so I decided to join them.
So he built the AtCoder site, and then you joined to create problems?
Yes.
Cool. So the second question is, what has your favorite thing about AtCoder been so far?
Well, I can decide programs used in AtCoder, so I think I like our programs the best. And many good people come to AtCoder, like Piotr or Tourist. So the level of contest is also very high, I think.
Yes, I've definitely seen that with the problems.
Yeah.
I've been using them to train my teams. So the next question is the Dan rankings for AtCoder from Go?
Yes.
Yes. Do you play Go?
I know the rules of Go, but I'm not very strong.
Yes.
But one of the members in our company is very strong at Go. I can type his name, Suzuki.
Oh, yes, I remember him.
He is very good at Go.
Yes. I remember lots of problems from him and or about him in TopCoder too. Yes. I recently started playing Go myself, but I'm not very strong either. So what is the philosophy behind the scoring system at AtCoder, and how did you come up with it?
What scoring system?
Just
strange system. So
just the way the scoring works for the scoreboard is different than Codeforce's or ICPC.
yes, but it should be different from Codeforce's because AtCoder doesn't have hack system.
Right.
And the scoring system is very natural, I think.
So how does it work exactly?
So the score is assigned for each problem, and if you solve something, you can get the scores assigned to the problem.
And
for example, if you solve 100 points problem, then you get 100 points.
And then the time penalty is just your last solve?
It's the last submission plus penalty. So I think it's almost the same as Google Code Jam.
Yeah, it's very similar.
So I think it's not something very special.
Okay, so the next question is, how do you come up with such creative problems, and what is your process?
So you are talking about my own problems?
Yes.
Very difficult to say. I usually find something interesting for problems like when I come up with something, I write it, and it's difficult to explain the process of writing programs.
Where do you draw inspiration from, though?
Sometimes it's some random mathematical object, and sometimes it's a modification of other programs. Or sometimes it's just some object from daily life.
Okay. So the
For example, when you play board game, then the board game can be something for I can use the rule of board game for writing programs. but it's difficult to say.
Yeah. Have you ever used Go as a board game to write problem idea?
It's not me, but I think CGI Forever used Go for writing programs. That's it.
Yeah. So the next question we have is, what is the meaning behind your handle RNG58?
When I started TopCoder, I didn't think that I will continue doing it for 10 years. And actually, I didn't think very well about my handle. And 58 is maybe you have seen I58. And
So I58?
yes, so 58 means that I was the 58th student in my high school, and Sky 58 is my classmate. So, and there are some other people like this handle. So, my classmates use this type of handles. 3 characters followed by 58. And the RNG part comes from Apple in Japanese.
So this comes from Apple?
Yes. But I don't remember why I decided to use Apple.
That's funny.
But it's not something very interesting. Just Apple plus common suffix.
So you said the other name was Sky58, not I58. So this was another,
Yes.
your classmate. I see. Cool. So the next question is, what was your motivation to start your new blog?
I wanted to write what I did in programming competitions. And one reason is to not to forget absorbing problems. For example, when I participate in contests, but when I didn't solve problems, I tend to forget solving them later. So I want to keep it somewhere. And sometimes I just forget solutions of problems I solved in old days. So I wanted to write about it.
So it's upsolving and remember old problems?
Yes.
Cool. And so the next problem is, what did it feel like? Our next question is, what did it feel like to win TCO the first time?
So for the first time, when I went to TCO for the first time, I didn't even imagine that I will win the contest. So it was very surprising.
Yeah.
Yes, it was surprising.
I remember the strategy was going after the hard problem first, too, or trying to solve the thousands.
Was that the first year?
I
don't
remember.
I participated in this show 3 times, and in some year I used that strategy. So
Oh.
when was that?
It might be 2011 and not 2010.
2011, I think.
Yeah.
And in 2010, I used standard strategy. So I solved from the easiest problems, I think. But after that, I participated in Google Code Jam. And in Google Code Jam, I can read all problems. And the last problems were something I'm very good at. So I went to the last problem and it went well. So maybe in 2011, I wanted to repeat the same thing. And that's why I started from the hardest problem.
So the next question is, what did you like the most about being the TopCoder admin?
TopCoder Admin. With TopCoder, I like TopCoder problems, and I think that's the best thing in TopCoder Admin.
Is you like the problems?
Sorry?
Oh, so you liked the problems the most about being TopCoder admin?
Yes, I write problems. I check problems from other people. Yes.
So
Yes.
oh, you had one more thing to say, right?
I want to say that I enjoyed TopCoder very much because I started programming in Japanese Olympiad in informatics when I was maybe around 15. But 1 year after that, I started TopCoder and I find it very interesting. And I spent much more time to programming competitions. So I grew in TopCoder, I think.
Yes.
Yes.
Well, you won TCO 3 times, so I think you grew a lot in TopCoder.
Yes.
So the next question is, who is your favorite problem writer?
It's difficult to choose one writer, but can I name several people?
Oh, yes, definitely.
So, for example, very strong people are also very good writers, like Piotr or Tourist, and they usually write problems for Open Cup or Petro's Boat Camp, and the problem sets are usually very good. And for AtCoder writers, Sugim48, maybe I can type his handle here. And also Sunuke. They write problems for AtCoder frequently, and their problems are also very good. And he's not very active recently, but then I studied TopCoder. I liked it solves the problem a lot.
Oh, yes. I like Misov's problems as well. I should put him under TopCoder.
Yes. So
Yes, and he's also the language
yes.
specialist.
So maybe there are more writers I like, but these people are examples of my favorite writers.
Very cool. And so our next question is, do you have a favorite problem?
Again, it's difficult to choose one of the problems. I think that AtCoder Grand Contest, and they, in those contests, I use the problems I think that I think very nice. So AGC's problems are something I like a lot.
Yes, I went through many of those AtCoder Grand Contest problems after we decided on 9270, and they are very nice problems, all of them. So if you haven't seen these before, you should check out the AtCoder Grand Contest for sure. It's a really good problem. So the next question is, what is your advice for how to train for programming contests?
Recently, there are a lot of contests on the internet, so I think you can just participate in many contests, and I recommend contests with good programs. So I think AtCoder is good, and you can participate in TopCoder, Code Forces, and some annual contests like Go-chan, Facebook Hacker Cup. And if you are from Russian-speaking countries, you can participate in Open Cup contests, Petersburg camps, and you can participate in all those contests, and after the contest, absorb some of the problems you didn't solve during the contest. And that should be enough, I think. For example, I was frequently asked that which book is the best to learn this algorithm. I get many those questions, but I think contests and absorbing is enough for the training. Of course, you should learn new algorithms when you find something you don't know, but I think that's good. Yes.
And so this next question is about travel. So where's your favorite place you have visited for a programming contest?
Petrozavodsk is a very interesting place because it was very cold. Like minus 25 degrees Celsius. So it was a very interesting place. You can walk on the lake because the lake is frozen. And I went to United States a lot of times, so I usually prefer different places because I new to those places.
What places did you visit in the United States?
Places around San Francisco is the city I visited the most times, I think. And I went to New York, Washington, D.C., Seattle, and many other places, I think.
I think you've also been to Orlando, right?
Yes,
Yes.
in
This
TCO,
is,
I think.
this is for me, Orlando is where I am.
Yes.
So I had to ask. All right, so now we have some questions people have left in the comments. Question was, what is your setup for programming contests? And what IDE or editor do you use? And what kind of computer?
I don't like complicated things to like. I don't like Visual Studio. I don't like Emacs or such things because I can't use them simply. So I prefer easier things like Notepad++. Do you know Notepad++?
Yes.
And I don't use any advanced things. Just use compiler and Notepad++. And just compile my code from command prompt in Windows. No. I recently use Sigmin, and I use G++ on Sigmin. But I don't use anything advanced. Sigmin should be.
Did I spell it wrong? Oh, yes. Yeah, I haven't used it. I only hear people say it.
Yes.
So that should be Sigwin. Okay, so when did you start training for contests? And how many hours a day did you train when you first started taking them seriously?
Oh, sorry. Can you repeat the question?
Yes. So when did you start training for contests? And how many hours a day did you train when you first started taking them seriously?
Yes. When I was a junior high school student, maybe I was 15 at that time, I participated in JOI, Japanese Olympiad in Informatics. And that's the first contest, I think. And my first training was like one day before the qualification round of JY, I think. But at that time, the contestants are not very strong because this was the second year of JOI. So almost everyone are new to programming at that time. But my first year's training is like 1 year later. When I started TopCoder, I started practicing seriously in practice room. Do you know practice rooms in TopCoder?
Yes.
Yes, I solved many problems in practice rooms.
And how many hours did you spend per day training?
I don't remember, but maybe I think I solve one problem set per day.
So one SRM a day?
Yes, but when I studied, that's deep to contest. So sometimes when I can solve quickly, I finish it in an hour, but sometimes 2 hours or 3 hours. Or I don't remember, but I solved a lot of problems in TopCoder practice rooms at that time.
How many problems do you think you've solved in the practice rooms?
I think I solved like 90% problems of all problems from SRM 300 to, is it 700 now? Yes, 700.
Yeah.
So I think I solved 90% of those 400 SRMs. So more than 1,000, I think.
Wow.
Yes.
That's a lot of training.
Yes.
So the next question we have for you is, why did you choose to participate in World Finals, ICPC World Finals 2013 and 2015 particularly? And it says the same year tourists competed.
Oh, I didn't know when will tourists will participate. So the tourist is not relevant here, but
This
in
is coincidence.
Yes, coincidence, yes. But in 2014, I didn't participate because one of my teammates is in the first grade and he is not very used to ICPC, so I wanted to wait for 1 year. And my teammate, one of my teammates was semi-expert. Maybe you have seen his handle.
What's his handle?
Semi-expert. I typed it in
Oh, yes, yes.
live chat. So he became stronger in 2015. So I waited for him to become stronger.
And so the next viewer question was, what is your favorite goodie that you won in a contest?
what is goodie?
Prize.
Price? Price. I think I don't receive many kinds of prizes. I received prize monies, computers, and some T-shirts. Usually those things are what I get, I think. So well, they are nice, but it's hard to find something special.
Yeah. Let's see. There was one question that were in the live comments.
Yes.
They said, have you considered writing a book with IWE? So this handle? And they're asking about a book.
So yes, I have a book written by him, but I think I won't write books because well, what kind of books do you want?
I don't know. It was Vic Fred asked the question.
Yes.
I think your blog will turn into a book if you do it long enough.
Yes, but I don't come up with contents I should write in a book. There are already many books that explain a lot of algorithms. So those books are not new, I think. And now I don't come up with contents I should write in a book. So I don't think I will write a book.
Okay.
Yes.
So I think what we'll do now is talk about your problem that we promised to talk about, which is this 90-270 problem. There's 90 and 270.
Yes.
Okay. So you can explain the problem, and I'll try to draw what you explain.
Yes. So I should explain the problems, and you write some picture in your screen. Okay. So you are given a sequence of 90 and 70 to 270. A sequence of these numbers. And you are asked to construct a polygon, and the internal angles of this polygon should be these numbers. I think this is impossible because the number of elements is an odd number. So
right. So if I
for
add
this
another
polygon, where did you start it? Where did you start?
Oh, so I just drew a polygon that wasn't the same. Here, I'll draw a new polygon.
So for this polygon, it corresponds to 90, 10, 270, 90, 90, 90, 270, 90, 90. So you are, for example, you are given this sequence and you want to construct this polygon.
Okay, so this is the input.
Yes.
And you want these points out.
Yes. This is constructive problem, so of course there are multiple possible solutions, but you can not put anything. And when this is impossible, you should just print -1.
Okay. And so you also don't want any of the lines to cross or any of the points.
Yes. Yes. So it should be a polygon. Well, maybe I can write the link to this problem. Do you have a link to this problem?
Yes, I have the link for the problem. So if anyone wants to see the problem, I've posted a link in the chat.
Yes.
And so, so how do you know if you should print -1 or not? If such a construction is possible or not?
Yes, so I should explain the solution now.
Okay.
Okay. So for -1, it is known that the sum of external angles is always 360. So if the input doesn't satisfy this condition, of course the answer should be -1.
So it has to equal 360?
Yes.
Is it internal or external?
External.
Okay.
So external angle means 90 for 90 and -90 for 270. And this sum must be 360. This is a well-known thing. And for example, in the example you give, this sum is 360, so the answer, well, you know that if this is not 360, the answer is of course -1, but you don't know the answer when this is 360. But it turns out that when this value is 360, then we can always construct a polygon. So the main question is that how to construct such polygon.
Okay. So how do we go about constructing the polygon?
Yes, so we can prove that when this condition is satisfied, one possible case is 90, 90, 90, 90, 4 90s. This case is easy because you can just draw a small rectangle. Yes, this is 90, 90, 90, yes. And except for this case, and when the sum of external angles is 360, then you can prove that there must be always at least one 90 and at least one 270.
So let's write out a small example.
Yes.
So we have a 270, 90, 90, 90.
And maybe you can use the previous example.
Oh, yes. Yeah, let's just look at the previous one. And so what you're saying is there's always a case where I have a 270 and 90 next to each other in one way or another.
Yes.
All right.
Yes. So, for example, in this example, you can find adjacent pair of 90 and 270.
Okay. And so once you find the pair, what do you do next?
Yes, once we find it, we just remove the pair from the sequence. Yes,
Okay.
this is the input, and we remove the first two numbers.
And so then we do this process again?
Yes, but yes, we find a pair again and remove it. And we can prove that this process doesn't change the sum of external angles. So if we repeat this process, we finally get 490s. And for each of these sequences, you can construct a polygon. So first you construct the polygon for the case with 490s. And that's just one rectangle.
And so now we have to insert back the 90,
Yes.
270 back in.
Yes.
Okay. So what is your method for introducing that 90, 270 back in?
So maybe you can choose which 90 corresponds to which 90.
Yeah, so I'll say the first one is here, and then I'll go clockwise.
Yes. So
we're
we want
inserting.
to insert a pair of 90 and 270 between 2 and 3. So we should do something for this edge. And we should, it's difficult to explain words, but you can modify this edge a bit.
So I think you said that first you expand the coordinates. So we have a 1 by 1 rectangle.
Yes, but I think I should describe the details later. So first I can explain how to do it by hand, I think.
So
you should add a small how to say it, but small modification between 2 and 3.
all right. And so
Yes.
the modification.
Yes, this.
So we have this and then 90. And then we insert a 90, 270. So this is a 90, a 270. And then we're back to the 90. So here's the 90, 270 I'm adding, and here's the original 90s.
Yes.
And so this right here is our small modification between 90 and 270.
Yes.
But we had to make room for it, right?
Yes.
So we doubled our coordinate space here.
So maybe you can repeat the same thing for
Oh yeah, for the next
hexagon
one.
to octagon.
So that adding the next one to the front and see how it changes?
Yes, yes.
Okay, so now we need to add a 90-270 to the front here. And so it needs to go 270, then 90. So here's, I'll double the coordinates again. So here's our original coordinates, and I expand them out by 2.
Yes.
And so that's our original shape. But I need to introduce this 90, then 270, like this. So I slide this coordinate over, and that's the new one added in.
Yes.
And now I have my 90, 90, 90, 270, 90, 90, and then the 90, 270 is at the beginning now. So this is the first coordinate, and I'm going in counterclockwise direction around this polygon.
Yes.
And that gives me my sequence.
He added a small modification to the left edge because we want to insert a pair of 90 and 270.
And so your
Yes.
technique, oh, you can go ahead.
I think I should describe the details of implementation because it's easy to do it by hand, but it's not easy how to implement it. So first, as he explained, we should double the coordinates because we want all coordinates to be integers. And if the coordinates are too small, we can't add modifications. So we should first double the coordinates. And now then you can add some small modifications like he did. But if you repeat this, the problem is that the coordinates will be too big because the number of elements in the sequence is like 1000.
Yeah,
Do you
it's
remember
1,000.
the constraints? 1000?
Yeah, so there are 1,000 elements in the sequence potentially, and you're only allowed to pick integers from 0 to 10 to the 9th. And so if we double it every single time, then by log base 2 of 10 to the 9th, we'll run out of coordinates.
Yes. So we should compress the coordinates after each operations. So maybe you can draw an example.
So I'll take this one right here and show you what the compression looks like. So you just find the key x and y coordinates that are relevant to the problem, and then you map them from 0 to n-1 so that every single position has a coordinate.
No. Yes.
Yes. And so this is the same shape, except now it takes up less space. And you will grow, now you'll only grow by 1 in the x coordinate or the y coordinate, depending on the type of insertion.
Yes, so by this compression, the maximum coordinate is at most all n, where n is the number of patches in the polygon. So you don't need two big coordinates.
All right. And so the way you're doing this, inserting, so we start with this original sequence,
Yes.
and then we find some pair 9270 to remove, and then that
Yes.
goes away. And so
Yes.
you're calling this recursively
Yes.
on the same problem.
Yes.
And then you're returning the XY coordinates of a sequence.
Yes.
And then you have to add back in the 9270 by modifying that sequence of points.
Yes.
Cool.
And each modification can be done in all n. So in total, the solution works in n square.
So our runtime, very cool. So is there anything else you'd like to add for this problem?
I think this is all from me.
Okay. So one person in the chat had a question for you that wasn't answered. So I think we should answer that question now.
Yes.
Yes. So he said, you said you were learning Russian some years ago. And he's asking, how did that go and how did it pay off in competitive programming and outside competitive programming?
Oh, yes. Well, in my university, I should choose one language, except for English. It's called the second foreign language in my university. And everyone chooses one of languages in, I think, German, French, Spanish, Chinese, and Korean, and Russian, I think. And I should choose one of these languages. And I chose Russian because that looks the most relevant for me, because I do competitive programming. I think you forget to write Spanish.
Oh, yes, Spanish. And so are open cup problems in Russian?
Yes, they are written Russian for Russian-speaking people, but you can also find English programs. So I usually read English program.
Okay.
Like code pushes. And I didn't learn it very well.
You didn't what?
Yes. But at least I understand. So I didn't do well, so I can't understand the Russian programs at all. For example, code forces. No, I see the comment in live chat, but I can't understand Russian editorials.
Oh, right. So he, yes.
But
So there was a
at least,
question
but
in
at
the
least
chat.
I learned characters of Russian characters.
Yeah, so you know the Cyrillic characters,
Yes.
but you can't understand the editorials. So the question that was asked in the chat was, can you understand Russian editorials? And so the answer is no. but he can read the characters.
Characters is not meaningless because, for example, when you go to Russia, you can find supermarket. And supermarket is written supermarket in Russian characters, so maybe I can type it. And when I went to Russia, I can understand that supermarket is supermarket. So you
Yes, I'll copy you.
characters, you understand this.
So let's see if I probably won't write these very well because I haven't studied Russian very much, but well, I will try.
One more interesting thing is that I typed into the comment. Have you seen this in Code Forces?
So you see
N and string character and M.
And so what does this one mean?
So it means N and M.
So these are like bounds for a graph, or
Yes, so we see this many times because they frequently forget to translate this. But at least I understand why they do such thing.
that's very cool. I think there was one more question in the chat that someone had asked.
Yes.
So they said, what is your advice for a new competitive programmer?
Yes, so the answer to that question is, I think, the same as what I talked before. So you can participate in many contests and you can absorb problems you can't solve. And sometimes you find new algorithms you don't know. So in such cases, you should learn that algorithm. And maybe even when you solve some problems, it's nice to check some codes of good people because they may have solved it in easier way. So when I started TopCoder, I usually spend lots of time to solve problems, but strong people solve it in like 5 minutes or 10 minutes. So after the contest, I check their codes and understand that how they can solve it so quickly.
So you read a bunch of code after contest?
Not a bunch of code, but usually
Okay.
one or two, but yes, even when you solve it, you can learn from others.
Very
And it
cool.
seems there are some new questions.
Yes, yes.
Yes.
So the question is it better to upsolve only the next problem that I couldn't solve on contest or the whole contest?
Well, usually it's difficult to solve the whole contest. So, for example, even now, I don't absorb all problems in OpenCap because some problems are solved by no people, and sometimes it's quite hard. So I usually choose a few problems that I don't solve during the contest, and I absorb them. So you can choose some of them. I think you don't need to absorb everything. Yes.
So only choose a subset, but choose the ones you didn't get. But not necessarily all of them, because some may be too hard.
So for example, if you participate in TopCoder, and for example, if you are new to Division 1, then maybe you don't need to absorb hard, but you should absorb easy and medium. And when you become stronger, you can try hard now. Yes.
And then for the Div 1 hards, delay until you become stronger.
Yes. When I started, I solved a lot of Div 2 hard.
Okay. Oh, and so you solved lots of Div 2 hard when you started, and then moved on. So here's another question: is how much time to spend thinking about the problem before looking at editorials?
Well, usually when I feel that I can't solve it by myself, then I read editorials. So for example, if you get stuck for an hour, then maybe you can read the editorial. Yes.
So if it takes you more than an hour to get unstuck, then you should read the editorial. That's a loose rule.
Well, this is not exactly, but when you feel that you can't solve, then you should read editorial.
Okay. But then you shouldn't read it right away. You should try to see if you make progress first.
Yes.
So we have another question. And it says, are you interested in any of the trending fields like machine learning, virtual reality, etc.? Do you try to learn these fields, or are you only focused on algorithms and competitive programming?
Yes. I think I'm not very interested in these areas. So I want to focus on algorithms. Yes. I want to focus.
All right. And then so the last question we have here is, do you watch anime?
I don't watch anime, but I know many people who watch anime. But I don't.
All right. So I think that's all the questions everyone's had for you. And so we had quite a few people tuning in this week that wanted to see and ask questions. So thanks you very much for coming on the show and talking about AtCoder and all your experience. So, and so thanks for everyone else for tuning in this week, and we'll have another episode again next Friday. And so thanks again to Makoto for coming on and being part of the show. Great. Bye, Makoto.
Bye.